Hey everyone, and welcome to a brand new explainer. Today, we're diving into something absolutely fascinating, the core philosophy of creating video game opponents that can actually think. We're going to unpack a massive shift in how virtual worlds are built, moving completely away from rigid, boring scripts and toward machines that genuinely learn and adapt.
Our guide for this journey is Matt Buckland's groundbreaking book, AI Techniques for Game Programming. This text gives us a literal peek behind the curtain of game development and shows us exactly how programmers are making computer opponents smarter, way more capable, and honestly, a lot more human.
Because, let's be real, we've all experienced the intense frustration of playing against a completely brain-dead AI. You know the exact feeling I'm talking about, right? You find a tiny blind spot in the level design, and suddenly the ultimate terrifying boss is just stuck in a corner, endlessly running into a wall. It totally shatters the immersion.
Stephen Woodcock hits the nail on the head in the foreword of our source text. He talks about how the ultimate holy grail for gamers is an opponent that learns and adapts to you as an individual player. Gamers don't just want an enemy picking from a menu of pre-coded choices, we want an adversary that actually figures out our tactics and actively tries to counter them.
So here is our roadmap for today. We're going to cover 1. The predictable AI problem, 2. The biological AI solution, 3. Building the foundation, 4. Evolving with genetic algorithms, 5. Thinking with neural networks, and finally 6. The future of gaming.
Let's kick things off with Section 1, the predictable AI problem and the limits of traditional coding.
Okay, so traditional games usually rely on these things called finite state machines, or FSMs. Think of them like massive, incredibly rigid flowcharts. They've been the backbone of huge hits, from Age of Empires to Quake. And sure, they're robust and pretty easy to debug, but here's the catch. They are incredibly predictable. If a programmer didn't explicitly write a line of code for a very specific scenario, the AI just completely freezes up. It has no clue what to do. Biological AI, on the other hand, that actively learns from its mistakes and dynamically evolves its strategies.
Woodcock points out that developers are literally hitting a wall here. He calls it the law of diminishing returns. Basically, trying to hard-code every possible player decision into one of those finite-state machines eventually becomes mind-bogglingly overwhelming. You end up with hundreds of fragile special-case logic scripts, and inevitably, the developer is going to miss a scenario, which leaves a glaring blind spot for the player to exploit.
Which perfectly tees up Section 2, the biological AI solution, a totally new evolutionary approach.
Leading the charge here is our author, Matt Buckland. Matt has this wild backstory. He was actually a corporate risk management consultant who got totally fed up with the money and office politics. So, he famously made a literal bonfire out of his expensive designer suits, threw on some jeans, and went off to program video games. His deep passion for evolutionary computing is the driving force behind this whole philosophy.
Buckland's biological approach is all about chasing that holy grail we mentioned. Rather than writing millions of lines of code to manually anticipate every single move you might make, developers give the AI a few basic survival guidelines. Then they just let it learn. It observes, it practices, and it evolves all on its own.
Moving on to Section 3, Building the Foundation, Matt Buckland's curriculum.
The book is actually structured to take a developer on a literal evolution of their own skills. It kicks off with a super solid grounding in Windows programming basics, like how the software actually communicates with the hardware to draw graphics on your screen. From there, it graduates the reader into the much more exotic, cutting-edge tech of genetic algorithms and neural networks.
That brings us right into Section 4, Evolving with Genetic Algorithms, Biological Problem Solving.
This is where we essentially bring the birds and the bees inside your computer. It perfectly illustrates digital evolution. Just like in nature, we're working with chromosomes and DNA, except here they're represented by binary numbers. Buckland introduces concepts like roulette wheel selection, which is literally spinning a digital wheel to favor the strongest pieces of code. He then uses crossover and mutation rates to breed those selections together, mixing them up to create even smarter, far more capable generations of code.
But what's really great is that he doesn't just stick to dry academic theory. You dive right in and apply these genetics to some seriously fun, hands-on projects. You build pathfinding algorithms to navigate a little character named Bob through a maze. You tackle the famously complex traveling salesman problem, forcing the AI to figure out the absolute most efficient route between multiple cities. You even use Newton's laws of physics to train an AI to safely pilot a lunar lander onto the moon. How cool is that?
Next up is Section 5, thinking with neural networks, giving opponents a brain.
So once you've mastered genetics, you move into this phase where you literally build your opponent a digital brain. You learn how to construct artificial neurons and synapses. This means working on awesome applications like training an AI to play a genuinely smart game of Minesweeper. You learn how to give your bot digital senses so it can dynamically navigate around obstacles. There's even a project called Recognize It, where you use supervised training and backpropagation, which basically means teaching the AI to learn from its own errors in reverse, to teach it how to recognize human mouse gestures.
By training an AI to watch expert humans play, rather than just forcing it to follow a hard-coded script, you get an opponent that genuinely plays the game. Woodcock sums up this transition perfectly. A traditional, hard-coded script is like reading a book about basketball. But a neural network that learns and adapts, that's like actually stepping onto the court and shooting hoops.
Finally, we reach Section 6, the future of gaming. Where do we go from here?
The final chapters of Buckland's text lay down the foundation for the absolute bleeding edge of game design. We're talking about incredibly advanced concepts like real-time evolution, where the enemy is literally adapting to your strategy while you are actively playing the game. It explores the creation of alien brains and even systems that can evolve their own neural network topology on the fly, completely bypassing traditional constraints set by human programmers.
Ultimately, all of this leaves us with one seriously thrilling question to ponder. If developers keep following this biological blueprint to its logical conclusion, empowering software with genetics and neural networks, how long will it be until we fire up a multiplayer game and simply cannot tell if we're playing against a machine or another human being? It is a wild future to think about. Thanks so much for joining me on this explainer, and keep learning.